Hello and welcome to the SCI-AI Podcast. This is episode number 38. Today we have Julia Nitsch again with us. This is round two with her. Julia is a roboticist focusing on the perception of autonomous robots. She has worked on multi-modal perception and machine learning algorithms for most of her career. It's been a great time last time with you, Julia. Welcome onto the show.
Thank you for having me.
Was As you know, with an estimate, women currently represent about 25% in the coding area or in the development sector, where you do coding and algorithm writing than compared to men, and they also get 30% less salary for the same job that men and women are doing, which completely kills me when I get to learn about it every day. And then I wanted to ask you, what is your perception of it? Is that although it is an absurd assumption of mine, could be, but do you think women code anywhere less than men when it comes to the quality of the code or the time it takes to write the same algorithm, etc.? Or do you think that men at critical positions have still not accepted that women can be as techy as them, even better than them? So yeah, please go ahead.
So I think I would like to answer first the question why we have so few women in the coding area. Actually, it's even less when we look at the DACH region like Germany, Austria, Switzerland. So the proportion is even less. So when we take a step really back and take a look at something like a YAF computer science competition, so for the school kids, when we have around the 10-year-olds, 11-year-olds, we see 50% of the participants are girls. So at this level, they are equally interested in becoming computer scientists, in robotics,
Right.
at least in programming. When we take a look then at this middle level, the competition when they are around 15, 16 years old, we only see 35% of girls participating, which is a huge drop, which even decreases to around 23% when they are 18 or 19. So what is happening? We are losing them between they are 10 and 18 years old. And this has multiple reasons. So first of all, sometimes girls still don't get the same encouragement than boys do when it comes to technical jobs. So it's still this stereotype about technical stuff is for men and other stuff is for women. So this is still so big in our society that we need to break this stereotype, because we have so few women in the technology sector. The girls don't have any role models they can look up to.
Yeah.
So especially in the German-speaking area, we have the stereotype of the coders who sit there in their hoodies in the cellar and do some hacking stuff. And this is something they don't want to become. So especially women in the coding sector have to show and really show up what they are doing also to the school girls. So really to encourage them. So this is a broad spectrum where you can work, and it's definitely not only sitting in your hoodie in the cellar. And this is something we need to break here. And yeah, so this goes further. So I mean, when we have this 23% when they are 18 and 19, and even less than in the computer science courses. Yeah, then the issue, as you said, is we have, when we enter then the industry, the working areas, we are in the minority. And still also with the education, which is still there, telling girls to be calm, only to ask in a very calm way for things. This is really a big issue when it comes to negotiating salaries. So men are more straightforward, more direct, also more pushy, asking for the things they want. And this is something which is based also on the education, which is still around telling girls to be calm and to be in the second row. This is where this is coming from, and we need to break it. And the question is now, of course, we can educate now the next generation and really start the change there, which is already happening. But what do
Right.
we do with these women entering now the market or the industry? And as I said the last time, I think one big opportunity which we have is really connecting with each other through female business networks, through
Right.
also company networks or female company networks. Especially big companies have these networks, so this is also in favor of the companies, so that you connect different departments with each other. So this
Right.
is something where we can do what we can do, and really women support other women, and also the more senior ones being role models for the younger ones. So this is where this comes into place, and I think with this opportunity we can really drive a change with the current generation entering the job market. This is one thing what we can do for the women. And I'm also very much in favor of showing men how it is to be in the minority. And what I see at technical conferences, so at least at one of the flagship conferences in robotics, they organize some kind of women networking events, like women breakfast or women in dinners in the evening. And sometimes women bring one of their colleagues and show them then a room full of women, and there's only one man inside or two men inside. And also this perception they get then when they enter the room, that this is something now feeling different simply just because they are the man, is also something I think we need to emphasize a little bit more when it comes to the working place. And yes, this is the thing where we need to work on both sides. And of course, a huge topic is still corporate culture. Really, when it comes to also being aware of these differences which we currently have between men and women, and really encouraging both in the same way, and addressing them also in a way that they feel encouraged. Maybe we have to address women a little bit different than men, to encourage them really both to step up, to go for the leadership roles, to go for the expert roles. And yeah, maybe we need there also a different approach how we address men. And if we are really working on that, then we can drive here a huge change.
But do you think the men at those positions of co-founder level or the CTO level, they would never want, by some strange reason, by some industry standards or the way they believed always, that maybe men are better at that, and you can have women just to fulfill that area, that we are equal opportunity employers, so they would push a few women there, but still at their heart or what they actually really want is only men. Do you think something like that still happens?
I really like to think that this is not happening anymore. So I'm really thinking positive in a way that we have this, or that everyone wants this diverse culture, because I mean, it's proven, it's scientifically proven that we need diverse teams to perform better. Still, you hear sometimes stories where this isn't the case. And I think this is really things we have to break. And I really hope that with the next generation really pushing to these levels, that we can drive the change we want. As I said, so this corporate culture. There is also a strong movement now in Germany, because due to the generations, a lot of people go to retirement and less people are moving up to their working life. And what we see here, we are missing a lot of working force. And I think that's really also the point where we simply have to encourage women as much as men to move up to those positions, because we are simply missing the people at some point. All the aspects which play together, that we're really driving the change now. And of course, you will have always people who are working against that. We see that in every area, not only in industry, you see that in politics, you see that everywhere. And I still like to believe everything is progressing and going further into generally a good direction. Of course, it's like in machine learning, the loss. Sometimes we have some steps inside where we have some drops, but then in general, the trend is going upwards.
It's quite logical, like you said. I mean, we have to be positive, and if we see the last 50 years of growth, I mean, women were not even representing anywhere in corporate culture except a few positions in maybe the level of secretary or assistant. But now women are, at the level where they're making startups like Canva and others, and that's phenomenal at the positions that they are. And men are accepting it because it's so logical, isn't it? I mean, it's, what is it to do with gender? I mean, all we need is progress, we need growth, we need more better people at the right positions. I mean, so can you please share with our viewers about how to be a coder? Because many of the viewers and people that I've interacted with, they are also interested in knowing which are the places or universities that are good for learning to code, also going into the field of artificial intelligence, machine learning in their careers, and not just universities, but maybe MOOCs, the massive open online course like Coursera and others. The people who are interested in making their career in robotics, AI, machine learning should have a prior background, something like a mathematics or science, or do you think nothing is needed? You just need a start somewhere.
That's a good question. So maybe before I answer all your questions, I can share a little bit of my way or
Yes.
how my education looked like, so that people get also a notion how I got into robotics. My robotics career started already as teenagers, and so some teacher just put a robot in front of me and told me, okay, let it drive, I don't know, a square, a rectangle, something like this. And that's how I got into robotics, really by trying it out, by doing. I chose a very traditional path in terms of university degrees, really going for a bachelor and master's degree. But I always had not only the theoretical classes, especially at the university where I did my master studies. We always had a theoretical lesson or course plus a practical lesson. So I really had this hands-on experience quite early, and also joined the students team in robotics where I really tried things I learned. So hands-on learning experience. This is also how I learned to do, let's say, also research in terms of whenever we had the hypothesis, we always tried it on the robots. We tried to do the field experiments with it. And that's how I continued with my PhD degree. I also always trying it out in the real robot. And yeah, for me, this was more the traditional approach, really going through the university levels. What we also see is, especially now, Germany and Austria and Switzerland, we have not only universities where you can do your education, but we say in terms of where you can learn a profession. Instead of doing a longer school education, you can choose with 15, 16 to learn a profession and really join a company and learn coding quite early, or IT infrastructure. So this is also a very, very hands-on approach to start really the learning. When it comes to really open source online courses, even paid subscriptions, they have great content, and what they really can do is democratizing the knowledge. So now nearly everyone who has access to internet can also access those lessons. So it's not something like the elite at universities who can access the knowledge. And that's the really, really great thing about these online courses. What I have to say is that I sometimes have the impression in these online courses that everything is really tailored to the course, so that all the exercises are already prepared. So you don't need to think so much outside the box when you are on the real robot, but everything is already prepared. Of course, you get the base knowledge and you learn how to apply it, but only in the setting dip. So if you need to step one side to the right or one side to the left, you have really a hard time still to apply the knowledge. So that's where I think is the big drawback of these online courses, in terms of you don't have the resources you have at the university or at when you're really learning the profession in a company, that you can try it hands-on the robots. But this is really, I think, also something special to the roboticists, where we always have something moving around and testing. So this is what I'm currently still missing in this online education programs. What I really like to think of is, even if you chose another profession in your first career path and you are interested into coding, you are interested into machine learning, you can still be a really, really good fit in this domain. We really need, or the problem what we have now with machine learning or data science is that we have a lot of people with the theoretical knowledge and really being experts in the models or how to train the models, but they are often missing the domain knowledge where they want to apply the machine learning or the data science model. So if you're really interested in this field, I think it's really good if you're the domain expert and start understanding what is machine learning, what is data science, so that you can team up also with a mathematician, with someone who is really focusing in this area, and then together really implement something. And once you learn the base models in your implementation, again hands-on, you're really good to go and to start with your own pilots, with your own implementation. So this is something you can still learn. So this is not something which should be restricted to mathematicians, computer scientists. This is really where we need to work together. Also, this is one of the biggest things which I'm currently seeing in industry, that the machine learning projects fail either because the wrong application was chosen or the domain expert was really missing there. But to say, okay, their machine learning brings the biggest benefit. I can just encourage everyone who was starting a profession somewhere and is now being interested in data science, go ahead, also get started with these online courses to get a notion what this is about. And then together with that mathematician, data scientist, really start working on a project.
No, great, absolutely great point. I'm pretty sure this will definitely help, based on your experience and the kind of advice that you're providing. So I'm researching on whether language can make you more intelligent. I've done a podcast with an author from India, and he was discussing about how in India people are actually still talking in English because, we had a colonial background when Britishers were there till 1940s, and so everybody is now using English to interact and study, and everything. You're not so intelligent because you're not talking in your own, or you're not reading in your own mother tongue or in your language. Do you think, from your experience, that if you would have had study in German all your life, like in graduation, even till the level of masters and PhD, do you think you would have had more easier way to grasp knowledge and to create more ideas and be more creative? Or do you think it's okay to adapt to new languages and then still learn in those languages?
Oh, that's a good question, and I think I have never thought about it. So I think I have to say that for me now, reading and writing in English is actually, especially in the technical area, is actually easier than doing that in German. Because in German, especially the writing is super complicated. We love sentences which go over 5 lines and have 3 sub-sentences, which are sub-sentences sometimes. So it's hard to read, and English is much clearer in the language. So this is, I think, something which is definitely a benefit. But when I think back, especially when we entered the master studies, my level of English was not good at all. So I really had also a hard time to adapt to English, to adapt to speaking in English, because the university at that time was not so international like other universities, so I usually spoke German. But for me, this was the language which I needed to communicate to other researchers, to other people in this area, which had a really, really interesting standpoint or viewpoint, and I wanted to understand. And since everything is written in English, so I think this was my main motivation really to get into this language. I know colleagues of mine had a much more difficult time to adapt to English, but we supported each other. So there was really the support from the others, and trying really to bring everyone to a level where he or she can communicate, write, and understand everything. So this was really a group effort here. But I also think we had a very, very different motivation, because in this technical area, it's simply English is the language. What I know and what we have to do if we want to communicate our technical progress or technical achievements, we really need to do that in the language of the country. So we also have a robotics explanation program, something like an online course, which was introduced also from the European Union, and it was translated into each language of the different states within the European Union, because you want to address the people, you want them to understand what's happening there, and therefore you really need the language of the country. So you don't need it at the university level, because still science is communicating in English. This is the way it is, and everyone who wants to join at this level has to learn English. But if you want to explain it to your grandmother or even to children and making them interested in this field, you need the language. And this is what I also see now is I'm volunteering here at the coding school. It's not a real school, so we call it inspiration sessions, where we at the weekend in online courses just make the kids interested into coding. And most of the resources are in English. So what we usually do is translating them to German and really trying to to make the children understand what's going on, and then doing it in German. I see so many great resources which are in English but not in German, especially at this educational level, which is really a pity. I think in this area we really need to go for the broad language spectrum.
As per you, how impactful do you think AI is in building robots that are fully functional without human intervention? And I'm not right now talking about the capability of the artificial general intelligence. Where I'm trying to get onto is something that is so powerful that it can virtually do everything around us and in our factories using robotics or other means that you can't think, but that can't think like a human with trillions of parameters that a human brain can do. So where I'm trying to get onto is more practical applications other than just the tool-based applications that AI is actually solving nowadays. Maybe just a step ahead from now, maybe like 10, 15 years or 20 years from now in terms of AI.
Yeah, so I think especially in 10 or 15 years, we will probably see now the potential which we see in startups, maybe also in research, applied in industry. So now we are talking a lot about Industry 4.0, about cobots, really supporting human in their doing in the factory streets. This is something which I really see coming in 10, 15 years. So I wish we would already have it by now, but still this time from the research really going to the industry is really long, especially for robotics, because you always have the hardware component and you always have the software component. And I still feel like this is the maximum complexity which you can get. And I think we need still more time to really bring these research efforts, which we just now saw, to the factories, to the industry. So for me, the topic cobots is a huge topic, but also everything which is really bringing things from A to B inside a company. We see it now already with some robots in some really specific factories. But for example, think of the airports where we have the luggage being moved around by people by now, and we have a huge chaos now in German airports. And I think those things which don't really need intelligent movement but could be autonomized, here we could see a huge benefit and freeing the workforce, which is now used in this area for other areas where we can't use the robots because it's too complicated, because it's too narrow, they can't move through. This is where I really see the big benefit. Yeah, and when it comes to artificial intelligence in general, so I still believe, as I said, so in 10, 15 years, we will see now the machine learning models we see in the research papers finally being applied in industry, because I still hope that we make a big step forward when it comes to data acquisition, data storage, and all this data handling, what we are currently doing in a much more efficient way in the industry, so that we can train our models much more efficient. And I still see some progress, or really some huge steps in terms of the accelerators, in terms of the hardware where we apply the machine learning models, that we really make it more easy and faster from the training to really the implementation and the usage of those models. And yeah, so in this short term, I think we will see the things applied, what we are talking about right now, as the big new thing.
Did some research on your profile. Your PhD topic was the explainable AI. So I wanted to ask you about that, because you may have experienced a lot of challenges as well in this field. Challenges like the method customization, learning bias, non-linear data, and problem solving complexities. How do you solve that, or do you think it's an industry issue, and it is not going to be solved like right now, and it is something that all AI researchers are working on it to solve it?
Yeah, if first statement here, I didn't work directly into the area of
Okay.
explainable AI, but of course, so I did my PhD in the automotive sector, where we are talking about safety critical applications. So you always get the question when you present something, and how can we certify that? How can we make sure that it's not doing something stupid? And of course, then explainable AI gives you some tools which you can use to check what the network is really doing. So what I saw a lot in this explainable AI sector is visualization of decisions, visualization of data samples. So trying to get away from the black box approach, in terms of I give data in, it's doing something, and I get a decision out. So it's really to start understanding what's going on there. My issue I always had with these visualizations is that it's more a qualitative approach. So we can put out one sample, we can visualize it, we can explain it, what's going on, but we can't really generalize on this single example. We can visualize, we can make nice pictures, we can also write nice papers about. When it comes to the industry usage, we have to say it always has to work. And what I found really, really interesting here is the research on formal verifiers for neural networks. Because they are giving you a notion or a hint when something is going off. So this is really something which I heard in a lecture, and I think this is really one big thing which we can use to start really the discussion about qualification, about certification, because there we have formal verifiers telling us if something is going off. So this is one aspect. And the second aspect is really looking into what we call out of distribution data. So we train the data on a specific data set, but what happens if we get a data sample which is simply not fitting to this data distribution? The neural network gives you an answer, tells you, I'm 100% sure this is object A, although it has never seen this object. And this is really something which we have to identify, where we have to say, okay, we can't make a decision on it because we haven't seen it. And this, in combination with these formal verifiers, I think this gives us really strong tools to make AI safe, which was the main intent also from this explainable AI, to really start understanding what's going on. But for me, this start understanding what's going on is a good step, but it's not the solution to the problems which we saw in industry at this point.
In Germany, we have heard that now the robots are being used for tutoring in universities. I've read it somewhere in the blog, replacing professors and instructors. How amazing that! how do you think that revolution is going to impact our future generations in terms of robots standing in front of us while students are making fun of him or whatever? I mean, I'm sorry, I'm just digressing. Do you think that without the human voice, the emotions, etc., that a professor possesses, and the knowledge, of course, the knowledge can be transferred to another brain, to an algorithm, but do you think that it makes any sense in technology?
Of course not. So we can't replace humans by robots. So I read this article too, and I think I have to explain a little bit what was going on there. So yes, this robot was just used to transfer knowledge, and not even to transfer knowledge, but I think just to ask the questions the students then answer. And the professor was still in the room, going around in the different groups and really trying to steer the discussions in specific directions. So I still believe we can't replace teachers with robots, simply because the whole aspect of empathy, of encouragement of the people is missing. So this is something I think we can't build the same relation to a robot that to a human, and this is simply what is missing, and where we say a robot can't replace a human. Also in all these social jobs about care work, about really helping other people, this will be a really hard time bringing in robots, because people really, what we saw now also in the pandemic is we are missing the connection to people. We are missing really being surrounded by people. We are simply social, and we need this connection to other people. This is what we can't replace with technology. Of course, as roboticist, I would be super curious seeing robots in the lecture and programming them and interacting with them, but still the human is the human, and we can't replace it.
I still remember my MBA days in Boston, and I'm still envisioning if that happened at that time and we would have had a robot professor. That would have been so much fun. I mean, we would have never attended a class. We would have rather recorded it and then heard it later, because for a human, more about interaction. It's more about understanding the other human and how that human respond to the insights or to the knowledge that the professor is providing. So about the Mars rover and the robots that NASA and SpaceX are sending to Mars. You being a roboticist, first of all, give us an idea of where robotics in terms of space exploration is today, and then if you can also share with us a little bit about what is now the next step. I mean, we know that it is sending samples to us with a lot of research, drilling into the Mars ground and the sand and the soil, and sending us the atmosphere levels and a lot of other data insights. But in terms of physically sending a much more advanced robot, what's your reading of all this in the coming near future?
Yeah, first of all, let me maybe draw the big picture here. So we are sending a robot to a place which we have never seen before. So we don't know anything about the environment. So we have to build a robot which is mechanically capable of doing nearly everything in an environment which we hardly can simulate on Earth, because we have no clue how it looks like, and probably the simulation is also not working, or not working as good as it's done in space. So first, really the mechanical issues. Then everyone who writes software knows we are introducing bugs. If you were to change something on the robot, it takes the connection takes forever to really get something there, or I mean, updates are simply not possible. So you have to be really sure about the things you're doing. And I think still the space robots are one of the most extreme robots in terms of resources. So you're not allowed to use too much power, because then it's shutting off. Yeah, you have close to no memory, because you need also to store all the scientific data which you want to send to Earth. And I think it's really one of the most extreme environments where you can send a robot without really testing it. And I mean, I'm talking about this because we are, I think since 10 years, industry is promising that the autonomous driving is just around the corner and it's coming. And we know the streets, we know how the street layout looks like, we know everything, and still it's not there yet. So it's, for me, this is really something super interesting, and why this whole space robotics is simply so amazing. And what I see now, or I mean, the time when Curiosity was sent to Mars, I mean, this was really a big news, big step, and I think it's still driving around. So it's, yeah, so this is something really where I see, okay, it can work. So if you're doing a good job on the robot, it can work and give you the data you need. What I think, or what I see now, the next step. So these robots are super expensive. You have a lot of experts really tweaking around bits and bytes that everything is working. And for me, the really big news was that when NASA announced, I think, the next robot they want to send to the moon, this Viper robot, they also want to use an open source software framework on this robot, also to reduce costs and to use things which are already out there in the community, and also to give it back to the community afterwards to release the code. And this framework is called ROS2. So this is one of the most or widely used frameworks in the robotics community. And I think it's really such a great sign of, first of all, how you can really, they trust open source so much they would send it to the moon. So this is really one big statement. And also then to bringing it back to the community, to releasing the code. So for me, this is, I think, even at least as amazing or exciting than really having these robots driving around for forever in an environment which you can hardly simulate or really think of as programmer. So this is, I think, for me, really the big next step. And I'm wondering now if this is really going around and NASA is using this framework, if industry is also adapting more towards open source, and that we see really this exchange between the companies. So less the competition, of course, you need to close up your USPs, really what makes you unique or your special algorithms. But in terms of framework, this glue code everyone needs, and which is consuming most of your time when you program it. So once we start really sharing and cooperating on this, what great next big things could be around the corner, especially from startups which don't have simply the programmer resources to write this huge code base.
Fascinating stuff. Fantastic, Julia. Then I think we should wrap it up here. Thank you for giving us your time.
Thank you for having me. It was a pleasure again. And yeah, looking forward then to the next time.
Thank you. Excellent. Bye-bye.
Thanks, you too. Bye.